Welcome back. In the previous lecture, we were talking about the cryptography and what are the different encryption methods are there. That is symmetric encryption and asymmetric encryption methods that we have seen. So now let us see what is the difference between the symmetrical and the asymmetrical encryption. So the major part here in both the way is key management. So key management includes the key generation, key exchange, key storage, key use, and replacement of keys used in an encryption algorithm. So key management is uh, the most difficult part of designing a crypto system. Uh, so many crypto systems have failed because of mistakes in their key management procedures, as said in the previous lecture. So, in practice, most attacks on cryptographic systems target the key management level rather than the cryptographic algorithms itself. It may be the public cryptographic algorithm or the private cryptographic algorithm, or we say symmetric or asymmetric cryptographic algorithms. So here, here you can. There are several essential characteristics of key management to consider. One, like key generation, as said, uh, your key verification, key exchange, key storage, key lifetime, and the key revocation and destruction. So let us see what is key generation then. The key generation, the first one, let me just highlight. Okay. So in this key generation, sorry. Okay. So in this key generation, it was up to Caesar to choose the key of his cipher. The Wegener cipher key is also chosen by the sender and receiver. In a modern cryptographic system, key generation is usually automated and not left to the end user. The use of good random number generators is needed to ensure that all keys are equally generated so that the attacker cannot predict which keys are more likely to be used. Whereas your key verification, some keys are better than others. So almost all cryptographic algorithms have same weak keys that should not be used. So with the help of key verification procedures, weak keys can be identified and regenerated to provide a more secure encryption with the Caesar cipher using a key of 0 to 25 does not encrypt the message, so it should not be used. The third one is key exchange. So key management procedures should provide a secure key exchange mechanism that allows a secure agreement on the keying material with the other party, third party, so probably over an untrusted medium. Third one is your key storage then. So on a modern multi-user operating system that uses cryptographic, a key can be stored in memory, and this presents a possible problem when that memory is swapped to the disk. So because a Trojan horse program installed on the personal computer of a user could then have access to the private keys of that user. Another one is the key lifetime. What is the lifetime of the key? So using short key lifetime improves the security of legacy ciphers that are used on high-speed connections. So in IPsec, a 24 hours lifetime is typical. However, changing the lifetime to 30 minutes that improves the security of your legitimate algorithms. And finally, the key revocation and destruction. So the key revocation that notifies all interested parties that a certain key has been compromised and should no longer be used. So destruction erases old keys in a manner that prevents malicious attackers from recovering them. So there are two terms used to describe these keys. One is key length, and another one is key space. So this key length, also called the key size, that we have seen for DES and triple DES, your AES and IDEA, the key sizes are changed. So this is the measure in bits. The key length is in the measure of bits, whereas key space is uh, this is the number of possibilities that a specific key length can generate. So these are two terms used to describe key or keys. So as key length increase, the key space increases exponentially. The key space of an algorithm is the set of all possible key values. So longer keys are more secure, however, they are also more resource intensive. So almost every algorithm has some weak keys in its key space that enable a criminals to break the encryption via a shortcut. Right. So the next few slides that explains about this key generation, verification, exchange, and storage and lifetime of that. So the key generation, as we just discussed, and the another one is your key verification, that some keys are better than the others. So almost all cryptographic algorithms have the same weak keys and finally key exchange, right? So this key exchange, that must be the keys between parties must be securely exchanged, and then key storage, so third parties are used to store the keys. And the lifetime is, as explained, that for IP security, around 24 hours lifetime is typical for any key. If it is reduced to 30 minutes, then it improves the security of the algorithm, the IP security. Then the revocation, as said, if any key is compromised, then it must be, revocate, and all the old keys must be destructed. So, in this symmetric versus asymmetric encryption, if you're comparing the encryption type, then you can find in symmetric key, it is best known as your shared or secret algorithm. So it is important to understand the differences between the symmetric and asymmetric encryption methods. So symmetric encryption systems are more efficient and can handle more data. However, key management with symmetric encryption system is more problematic and harder to manage. So whereas in asymmetric uh, cryptography, is more efficient at protecting the confidentiality of a small amount of data, and its size and speed makes it more secure for tasks such as electronic key exchange, which is a smaller amount of data rather than encrypting a large block of data. But maintaining confidentiality is important for both data at rest and data in motion. So in both cases, symmetric encryption is favored because of its speed and the simplicity of the algorithm. So some asymmetric algorithms can significantly increase the size of the object encrypted. So therefore, in the case of data in motion, use public key cryptography to exchange the secret key, and then symmetric cryptography to ensure the confidentiality of data sent. So if you summarize this, then the usual key length of your symmetric key is 80 to your 256 bits in size, whereas in asymmetric key you will find that 512 to 4096 bits in size. So these symmetric algorithms are usually quite fast, as just explained, and these are slow. The asymmetric key algorithms are slow because it requires some computations. So the examples, as we just described, this data encryption standard triple DES. So in the first DES, it encrypts the plain text. Then in the second DES, it decrypts that plain text, and in the third one, it encrypts again. So it used two different keys, at least. Different keys are used at each different phases. Whereas in example of your asymmetric keys are RSA, your elgamal or elliptic curve, and the DH algorithms are used for it. So now let us see what are the applications of this symmetric and asymmetric key application. So let me just quickly discuss that. So there are many applications for both symmetric and asymmetric algorithms, but a one-time password generation token is a hardware device that use the encryption to generate a one-time password, right? So a one-time password is an automatically generated numeric or the alphanumeric string of characters that authenticates a user for one transaction of one session only. So the number changes every 30 seconds or so. So the session password appears on a display and the user enters that password. So the electronic payment industry uses the triple DES, and the operating triple DS. The operating systems uses the single DES to protect user files and the system data with passwords. And most encrypted file systems, such as NTFS, uses the advanced encryption standards. So there are four protocols to use the asymmetric key algorithms. One is Internet Key Exchange protocols. They use the asymmetric key encryption. One is the Internet Key Exchange one. So in this, uh, the Internet Key Exchange is a fundamental component of the Internet Protocol Security Virtual Private Networks, or we call the VPN, the Virtual Private Networks. And the second one is Secure Socket Layer, SSL. So, which is a means of implementing cryptography into a web browser, that is for remote control. Another one is Secure Cell, which is a protocol that provides a secure remote access connection to the network devices, the SSH. And another protocol which uses this asymmetric algorithm is pretty good privacy protocol, PGP, which is a computer program that provides a cryptographic privacy and authentication to increase the security of email communications. So a VPN is a private network that uses a public network, usually the internet, to create a secure communication channels. So a VPN connects two endpoints, like the remote computer or server here in this case. There are two endpoints. It connects two endpoints, such as to remote offices or the internet, to form the connection. So this VPN uses the IP security. It uses the IPsec, Internet Protocol Security Service, that allow for authentication, integrity, access control, and confidentiality. So with IPsec, remote sites can exchange encrypted and verified information from remote computer to the office computers or the servers. So the data in use is a growing concern to many organizations. So when in use, data no longer has any protection because the user needs to open and change the data. So system memory holds data in use and it can contain sensitive data such as the encryption key. So if criminals compromise data in use, they will have access to data at rest and data in motion. Right? So with this, we'll just stop this the symmetrical versus the asymmetrical encryption. In the next session, we try to discuss the types of access controls.